Hey everyone. So today I'm going to talk about ionic compounds and how to balance them. And what I mean by balancing them is how do I make it so that they have a neutral overall charge? Okay. So, learning intentions and success criteria for this lesson. The learning intention to understand what ionic compounds are and how they're formed. We've been working on this a little bit so far, but today we're going to mostly focus on this success criteria. I can represent ionic compounds using properly written chemical formulas that are neutrally charged overall. Okay? Now, in order to do this skill, we have to first be pretty good at identifying what charge an ion is. So I want to take a quick moment and kind of rehash that, just go over it again real quick. So, as a reminder, ions form because atoms want to have a full outer shell of electrons. And so what happens is if their outer shell is not filled, then they will either gain or lose electrons to end up with a full outer shell of electrons. And without getting too into the details of how this works, what I want to focus on is just how to identify what charge an ion is going to be. So here's kind of the process for this, okay? The first thing we have to do is we have to identify how many valence electrons an atom is going to have. And we can find that out using the periodic table. So here's what we're going to do. Because we're mostly focusing on main group elements, we're going to just pretend that this middle section of the periodic table doesn't exist. Okay, so I'm just going to kind of cross out this middle section. Okay, we don't need this section right here. Okay. Okay, we're going to pretend that that middle section doesn't exist for this part. So here's how we can find the number of valence electrons. All we have to do is count these main groups, these taller columns, okay? Whatever number it's in, that's how many valence electrons it's going to have. So for instance, hydrogen and lithium and sodium and all these guys right here in this first column right here, all of these are going to have one valence electron, okay? Following the pattern, the next column over, all of these have two. We're ignoring this middle section, so we're going to go ahead and skip that. And then, by the way, that includes these ones on the bottom. Okay. This next available tall column, it's number 13 officially, but all of these have 3 valence electrons. Next one's 4, and so on and so forth, 5, 6, 7, and 8. Okay, so there we go. Now, there is a rule called the octet rule, and it says that atoms want to have 8 valence electrons in order to complete their octet. There are exceptions to this, okay, but generally speaking, they want to have 8 valence electrons. So here's how this process works, because they're going to either gain or lose electrons in order to follow the octet rule, the rule I just gave you. So what you do is you find whatever element you're looking for. Okay, let's say we're talking about sodium. Okay, sodium is right here in column 1. Okay, now sodium has 1 valence electron. Okay, now the question that you have to ask yourself is the number of valence electrons of the atom I'm looking at, is it closer to 0 or to 8? Okay, because either one of those situations, if it goes to 0 or to 8, it'll result with the atom being happy. It'll satisfy the octet rule. And it doesn't actually care which one it goes to. It just wants to go to one or the other. So whichever one is closest, that is the direction it's going to go. So 1, if you were to think about this as like a number line, 1 is closer to 0 than 8. Okay? So if an atom has 1 valence electron and it wants to go to 0, meaning it's going to lose all the electrons in its current valence shell, how many electrons, well, first of all, does it need to gain or lose electrons? If it's at 1 and it wants to go to 0, it's got to lose electrons. Okay? How many does it have to lose? Well, if it's got 1 and it wants to go to 0, it has to lose 1. I'm sorry, I misspoke. Okay? Now, we have established it's going to lose one electron. Now, here is the deal. We have to figure out what charge this is going to end up being, okay? And the way we do that is by figuring out how many electrons are gained or lost, okay? For each electron lost, because electrons are negatively charged, the resulting ion is going to have a positive charge equal to the amount of electrons lost. Okay, let me kind of diagram it out this way. Sodium starts out with 11 protons and 11 electrons. So I'm just going to put 11 pluses, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And it has 11 electrons, meaning 11 minus charges. 1, 2, 3, 5, 6, 7, 8, 9, 10, 11. Now, ordinarily, in the atom, these cancel each other out, like so. Meaning, for every positive charge, there's a minus charge to cancel it out, and it has a 0 charge overall. But if sodium loses an electron, now we've got a proton, a positively charged proton, that is not accounted for. It's not canceled out. So this means that sodium will have a positive charge overall, and we write this like so, okay? So sodium would have a positive charge, okay? And we can apply this to all of the different atoms in that column. So for every atom that has one valence electron, its ion is going to be 1 plus. It's going to have a positive 1 charge. And we can follow this pattern along. All of the ones in column 2 are going to have 2 valence electrons. 2 is closer to 0, so they're going to lose those 2 electrons, resulting in all of these having a plus 2 charge. 3 is still closer to 0, so they're going to lose those, and it's going to be 3 plus. The ones with 4 valence electrons, we ignore those because 4 is in between 0 and 8, and a lot of these have special rules, so we're just going to ignore those for this, okay? Once you get to 5, though, now 5 is closer to 8. So instead of losing electrons, it's easier for it to gain electrons. Because if it has 5 electrons, its choice is they either gain 3 electrons or they lose 5 electrons, okay? And because electrons are negatively charged, gaining 3 electrons to get to 8 will result in these all having a minus 3 charge. Similarly, the ones that have 6, they're going to have a minus 2 charge. 7, they're going to have a minus 1 charge. And then all of these that have 8, they're already at 8, so they don't want to gain or lose anything. Okay? So this is the general pattern. How many valence electrons does it have? Is it closer to 0 or 8? That determines if it's going to lose or gain, and then you just figure out how many does it have to lose or gain in order to get to 8 or to 0. Okay? So let me clean this up a little bit. Get rid of this part right here. Okay. We'll leave all the rest for that. Okay. So now let's kind of get to the meat of this lesson. So the issue is when ions come together to form ionic compounds, they have to be neutrally charged overall. And this is actually a really easy process when they have matching charges, meaning the cation is like +2 and the anion is -2. When that happens, they just snap together, the charges are already canceling each other out, and we're good. But what happens if they don't match? If they don't match, we have to employ something called the crisscross method. And we can see a diagram of that right here. Okay? So in the crisscross method, the charge, the numerical charge of the cation becomes the subscript of the anion. And the numerical charge of the anion becomes the subscript of the cation. And what this does is it makes it so you increase or you change the number of copies of each of the cation and the anion to end up with something that is balanced overall. Okay, so in my example right here, for instance, magnesium has a 2+ charge and bromine has a -1 charge. And so because they're not balanced, if I was to just put these together, I would end up with MgBr, right? But because magnesium is a 2+ charge and bromine is a 1- charge, overall, this whole compound would have a +1 charge. And that's not allowed. Ionic compounds have to be neutrally charged overall. So what do? In order to solve this problem, if we use this crisscross method, what ends up happening is we end up making a second copy of bromine, but we only have one copy of magnesium. Okay? This takes advantage of the fact that you can multiply in either direction and you will still end up with the same answer. Okay? So in this example right here, we end up with, instead of one magnesium with a 2+ charge and one bromine with a 1- charge, because the 2 becomes the subscript for bromine. Remember, the subscript is how many copies of that element you have. What we're saying is, okay, instead we're going to deal with 2 copies of bromine. And so now if we total this up, we have 2 positive charges and 1, 2 minus charges. So as a result, MgBr2 will have a neutral charge overall because there's 2 -1 bromines here. Okay? All right. So let's look at an example of this. Okay. So it says, what is the chemical formula for an ionic compound formed between strontium and chlorine? Okay. So the first thing I need to do is I need to identify what charges these are going to be. So let's look at my periodic table real quick. Strontium is right here. It's a group 2, so it's going to have a +2 charge. Chlorine is over here in group 17, which means it's got a -1 charge. So strontium is 2+, chlorine is -. Okay. Now, ordinarily you leave the 1 off, but for the crisscross method, I'm going to write it there so that way it's easier for you to see. So here's what I'm going to do. The number from the charge of the cation, just the number, is going to become the new subscript for the anion. And the number from the charge of the anion will become the new subscript for the cation. So when I copy these over, okay, it's going to be SR, and the 1, it's going to have a 1 subscript. But remember, we don't write 1 subscript, so I'm going to remove that. And chlorine is going to have a subscript of 2. So as a result, my compound is going to be SrCl2. And this is my answer. Okay? And if I were to double check this, right? Strontium has a 2+ charge. Chlorine has a 1- charge, but I've got 2 of them now. And so now I have 2 minuses here and 2 pluses here. And so we're balanced. Okay? Let's look at another example. It says, what is the chemical formula for an ionic compound formed between aluminum and oxygen? Okay. So, same deal. But this time, I've got aluminum and oxygen. Aluminum is going to have a +3 charge, oxygen a -2 charge. 3+, 2-. Okay? So they're not matching, so I need the crisscross method. So the number from the charge of the cation becomes the subscript for the anion, and vice versa. So I end up with Al2 and O3. Push them together, Al2, O3. This is my new compound, and if I were to double check this, aluminum has a 3 plus charge, and there's 2 of them. Oxygen has a 2 minus charge, and there's 3 of them. So plus 3, that's plus 6, minus 2, and there's 3 of them, that's minus 6. So there's 6 pluses and 6 minuses, which means we are neutrally charged overall. Okay. Okay, let's try a we do one. So here's what you're going to do. Okay. On your pair deck, you're going to do the one on the right. I'm going to do the one on the left. So what I want you to do is I want you to mimic my steps here to make sure that you get it correct. So it says, what is the chemical formula for an ionic compound formed between sodium and chlorine? So I'm going to find, I've got sodium, I've got chlorine. Okay, let's find those on my periodic table. Let me clear this off real quick. Okay, sodium's right here, it's got a +1 charge. Chlorine's right here, it's got a -1 charge. Okay, 1 plus, 1 minus. Okay, so I got lucky here. It's 1 plus and 1 minus. They're already balanced with each other. So because of that, I don't have to change the subscripts. I just push them together. NaCl. This is my compound. Okay. I got one more for you. Mine says, what is the chemical formula for an ionic compound formed between gallium and sulfur? So again, you're not doing mine. You're mimicking my steps to do yours. Okay, so you're going to do aluminum and chlorine. Okay, so I'm going to go to my periodic table. Clean up from the last one. Okay, I have gallium and sulfur. So gallium's got a +3 charge. Sulfur has a -2 charge. Gallium 3 plus, sulfur 2 minus. Okay, we're going to do the crisscross method. Okay. So my S kind of got covered up right here. Let's try and clean that up a little bit. Okay, so gallium gets the 2, sulfur gets the 3. So my formula is going to be Ga2S3. If we check that, there's going to be 2 galliums, each with a 3 plus charge, for a total of 6 pluses. And there's going to be 3 sulfurs, each with a -2 charge. 2, 4, 6 for a -6 charge. We are balanced. This is my compound. So use this skill, finish your we do question, and then try the you do problems for yourself.